All right, hello students. Welcome to Unit 8, Notes Section 12.5. In this set of notes, this is our last one, we'll cover circles in the coordinate plane along with completing the square. So you notice that everything but completing the square is in 12.5. You just have to flip through your notes a little bit further and you'll get to the CUDA worksheet on completing the square. As you can see, I did the warm-up already. To save time, feel free to pause it and then compare your answers with the answers that I received. What you are going to need to do is you're going to need to either use the distance formula, which is listed here again for you to do or use, or use the Pythagorean theorem. So create a right triangle and work with side lengths. You'll notice that in number 2, I kind of did a little of everything. So I did some distance formula for 1 and 3, and in number 2, I did the Pythagorean theorem. Either way is correct. I cannot stress it enough to be careful about your negative signs. For instance, a double negative, like in this one, is a positive, and and in this one, when I square -3, I get a +9. Do not put -3 in your calculator and square it and write -9 because you will be incorrect. You are squaring the entire negative with it, so you always get positive numbers for under the radical after you're done, doing what you need to algebraically. So feel free to pause it, compare your answers, and I am going to move on to the first slide. So with circles, here is the standard form of a circle. Well, let's talk about it first. The center is represented by h comma k. This is our center. It's represented as a coordinates x comma k, h comma k. And the circle, it doesn't matter what point I pick along the circle. Any of these that I'm kind of labeling out here, they can be any form of any number, but we're going to call it x comma y. So x comma y is any point that lies on the edge of the circle. What did they use? They don't use the word edge. Let's say that lies on the on the circle. So x comma y is any point that lies on the circle. I'll put it right near that one. And r is our radius. And that's pretty self-explanatory. So here's my equation. Going from the distance formula, instead of doing d equals x2 minus x1 squared plus y2 minus y1 squared and finding the square root of that sum, we actually replace it with our x and our h and our y and our k. Therefore, we have the standard form of an equation of a circle with center hk and radius r is as seen below. And h and k become your center, but it's also where it's a vertical and horizontal shift. It's a vertical and horizontal shift of your circle, which puts your center where it belongs. Now, h and k are positive, right? And they are only positive because they're in quadrant 1. Regardless, if it was in a different quadrant, it would be negative. What we need to be careful that we do, we need to always find the difference between x and h, and y and k as well. So what that means is that if we have 3 and 5, for example, let's say my center is 3 and -5, and my radius is 4. Well, when I go to write an equation of a circle, it's going to be x minus 3 squared, because really it's a positive 3. I'm taking that away from x, so x minus 3 squared. And then the next one is going to be y plus 5, or in this case, let me write it as a minus a negative 5 squared equal, no, I'm just going to go right into writing it as a plus because I don't want to make it more complicated, squared equals 16, which is r squared. So the equation of your circle with center 3, negative 5 and radius 4, well, we have to square the radius, so that's my r squared, and then 3, we're going to use 3 here, and we're going to use, and because we're taking away, it's negative 3, and then when we take away a negative 5, we get a positive 5. So there you go, that's the first equation of your circle. Kind of like when we were doing translations, and we were kind of writing it opposite of what we were doing when we were working to slide it left to right and up and down. So that's your standard equation of a circle. So here's another one. Write the standard equation of a circle with center 5, negative 2 and radius 7. Well, it's x minus h squared plus y minus k squared equals r squared, which is kind of like leg squared plus leg squared equals hypotenuse squared, right? Leg squared plus leg squared equals hypotenuse squared. And all of a sudden you see a right triangle show up. So we're going to fill in the rest of this answer. It's x minus 5 squared plus y plus 2 squared. We're going to use opposite signs for each one. And r squared is going to be 49. We always write it as, we don't write it as 7 squared. We write it and leave it as we'll write it and leave it as 49. We don't leave it as 7 squared. Whoops, that was weird. One more time. There we go. Good. All right, let's do a couple more. This one will have the x minus 3 squared plus y minus 5 squared equals 36. That one's done. And, whoops, having trouble with the highlight feature. There we go. And, oh, this one, okay, so a lot happening. We get x plus 2 squared plus y plus 1 squared equals, let's take a look. We're going to do this, the square root of 2 squared. So this was my h, this is my k, this is my r. I'll label all these h, k, and r just so that you see where I'm pulling them from. H, k, and r. It's really x, y, z, but I mean x, y, r. So h, k, r. Yep, and h, k. Okay. So we have this one, and so now what's the square root of 2 squared? Well, it's the square root of 2 squared is the square root of 4, which is 2. So I just get a result of 2. And that's it. And that's my final answer. Cool. All right. Write the standard equation of a circle with center 1, 3 that passes through the point 2, 2. Okay, well, it looks like I have my, if I'm not mistaken, I have my h and my k. I have my x and I have my x and y. Huh. Well, to write the equation of a circle, all I really need is I have x minus h squared plus y, oops, y minus k squared equals r squared. I want to, I need to find, an h, a k, and an r. I don't need x and y. I just need h, k, and r. But unfortunately, it looks like this problem only gave me h and k. It didn't give me any r. That's not bad. I can find r just by here's my r radius. I can find it by doing the distance formula or by doing the Pythagorean theorem. So I can either use this equation. Well, this equation is going to give me, this is no different than x2 minus x1 squared plus y2 minus y1 squared equals r squared. But it's just gonna, I might as well use it because I have it right in front of me. So here, my h and my k, let's see, I have h and k is 2 and 2. And then this coordinate, oh, I apologize. This is my h and my k. This is my x and my y. I can just use the circle formula. I could use distance, I could use Pythagorean theorem, but it already gave me the order. It already determined for me what my x2 and x1 were going to be, and my y2 and my y1. So I'm just going to evaluate it as 2 minus 1 squared plus y is 2 minus negative 3. So 2 minus negative 3 squared equals r squared. So 1 squared plus 5 squared equals r squared. So 1 plus 25 equals r squared. So we get r is 26 is r squared. Whoops, 26 is r squared. So we already have it just the way that we need it to be. So I'm going to say that I'm going to fill in the pieces I need. X minus h, so x minus 1 squared plus y plus 3 squared, because I'm doing the opposite of 1 and opposite of negative 3, and equals r squared, which is 26. See, using this formula gives me r squared. It doesn't solve for r. I can go further and solve for r, but why would I do that when I need to find r squared anyway? So I already have my r squared, and I just substitute that in for the given, oops, I substitute that in for the equation of a circle in standard form. All right, you're going to do the same one for this one. So center, let's label the center as h and k, and it passes through the point on the circle, which is x and y. I don't know my radius. I need to find my radius. So using x minus h squared plus y minus k squared equals r squared, I can solve for r squared. So x, I get negative 1 minus 2. Is that what that is? 2? Yep. Negative 1 minus 2 squared plus, kind of getting sloppy, I'm sorry. And then y is 1 minus k is 3. So I get negative 3 squared plus negative 2 squared is r squared. So 9 plus 4 9 plus 4 equals r squared. 13 equals r squared. It wants me to write the standard form of the equation. The radius, in reality, the radius is the square root of 13. But I'm not interested in that. I'm interested in writing the equation in standard form. So it's going to be x minus 2 squared plus y minus 3 squared equals 13. Because I need to write it in r squared when it's in standard form. Alrighty. Write the equations of the following circles. These are a little bit quick and easy. So let's do. I'm gonna do B. No, I'll do B first. Be careful. These axes are counting by 2. Okay, so 2, 4, 6, 8, 10. 2, 4, 6, 8, 10, 12, and so on. All right. I'm gonna write that this is at 420. And it has a radius of, that one is 4 comma 20. This one is going to be 16 comma 16 comma 10. And this one has a center of 0 comma 0. And well, I don't actually have to do any formula because I can just do this. Whoops. I can just count how long that radius is. That's a little bit too much. Let's do this one. The radius, it doesn't matter. Let me go this way. The radius, I'm going to do radius this way. I'm going to do radius this way. Okay, it looks like, yep, that's the font I want. Okay, this radius is going to be 2, 4, 6, 8, 10. It's 10 log. R equals 10. I just counted because it falls nicely on the circle. It goes from 4 all the way to negative 6. It has a length of 10. This one is, we're counting by 2, so 2, 4, 6, 8, 10. That one also has a radius of 10, right? 2, 4, 6, 8, 10. Yep. This one has a radius of, it looks like 12. 2, 4, 6, 8, 10, 12. Yeah, so 12. That's not what I want. R equals 10, R equals 10, so R equals 12. Okay, I'm going to write the equations for all of these. So it looks like this one is going to be B is going to be, circle B is going to be x minus 4 squared plus y minus 20 squared equals 100 because it's R, remember again, R squared. Okay, circle A is going to be x minus 16 squared plus y minus 10 squared equals 100. And then circle C, no, circle O is x minus 0 squared plus y minus 0 squared equals 144. Now what you notice is you don't need to write circle O that way. You can write circle O as literally x squared plus y squared equals 144. You can only write it this way, right? You can only write it this way when, whoops, looks like it didn't change. You can only write it this way when the center is 0, 0, the origin. So if you ever have 0 for either for either h or k, um, you can ignore the zeros. You don't need to write it with the zeros. Just kind of ignore them. Okay. So that's that. Find the center and radius. So working backwards, here's the center and radius. This one, you have a center is going to be opposite negative. So it's the true 7 that's there. So it's 7. And then the only way to get this would be to write it as y minus negative 2. So it's the negative 2. It's just opposite. You're just writing the opposite. And then the radius is the square root of 64, which is 8. So remember, if you're going backwards, change it. If it's negative 7, make it a positive 7. If it's a positive 2, make it a negative 2. Don't forget to find the square root of your number on the other side of an equation, because that is your radius. It's the square. R squared is what you see there. So in that case, you kind of have to think about it like this. R squared is 64, so R has to be 8 because I'm finding the square root. Think about this as just a 7. Think about that as a negative 2. Boom, and then you have your center and radius. This one is going to be a center of 2, 3 with a radius of, you guessed it, 10. All right, so I'm going to graph this first one here. I'm going to graph this one there. Oops. So this one's 7, negative 2 with a radius of 8. So 7, negative 2 with a radius of 8. 2, 4, 6, 7, negative 2, radius 8. I'm going to have to count by 2s. So I'm going to count, my axes are going to count by 2. Just to get it to fit on here. So 7, negative 2. So 2, 4, 6, 7, negative 2. That's my center with a radius of 8. 1, 2, 3, 4, 5, 6, 7. That one's going to go a little bit off. It's okay. And let me see. So 8 is going to go a little bit off. Whoops. Okay, I'm going to try my best here. That's about, so it's a little bit large. Okay, that's better. That looks pretty good. Looks like it's going to be 7, comma, negative 2 with a radius of 8. Because I'm counting by 2s, remember. In this one, oh, so if it's 7, comma 2, that means you can add or subtract 8, because that's your radius, from 7, and that will give you your high and your low. So 7 plus 8 is 15. So that's your x-axis, so that's about 15 right there. And then 7 minus 8 is negative 1, and that's where you kind of see right there at negative 1. It's a little bit in between. Then you add or subtract 8 from the 2. Oh, and that actually, yeah, so 2, 4, 6, 8. 2, 4, 6. So I can slide this down a little bit, and then that would be even better. Yeah, it's a little bit short, but that's okay. All right, this graph, 2 comma 3 with a radius of 10. I'm going to have to, again, count by 2's. So I'm going to count by 2's. 2 comma 3, so 2 comma 3 with a radius of 10. So radius of 10, I'm going to go 5. One, two, three, four, 5. 1, 2, 3, 4, 5. Take this with a grain of salt. 2, 4, 5. I think I need to move it up a little bit. Okay, that's about what you're gonna get. It's a little off. Yep, see, I'm afraid of doing that because it's too much. Let's just say that that's that. Whoops. Say that that's that. Here we have a radius of 10, and we have a center 2 comma 3. Again, add or subtract 10 from 2 and add or subtract 10 from 3. That will give you your difference of your y's and your x's, and it'll show you how far you're going to go on each of the axes. So really, if I'm going 10 this way, I'm also going 10 this way, and I'm going 10 this way, and I'm going 10 this way. I'm going 10 in this way, but that's a diagonal, so I'm not going to go 10 diagonal. You're just going to go 10 linear units left, right, up, and down, and that will give you that will gauge your circle, and then you're going to have to sketch it as best you can. All right, so you have all these questions to answer. So this is where class work starts. And as we keep going, you'll have plenty of questions along with even more questions and more questions. There is one last topic I need to do, and I'm going to try to keep it short and sweet. This one is completing the square of a circle. And it's happy April. We're almost there. Let's say you have an equation in this form, and this is kind of gross. It's not in standard form. We want standard form to look like this: x minus h squared plus y minus k squared equals r squared. We want it to be in that form. So it looks difficult. Like, how would I even start writing this one in this form? I'm going to show you a strategy that will always work. It's called completing the square, and you might have used it for polynomials. We're going to use it for each one of the individual polynomials, the x's and the y's. It's actually going to be quite easy. What I need to do is, in the simplest form here, I need to add things to this side and add things to this side, or take away from this side and take away from this side, to make it really nice and balanced so that I can just factor it right away. And to do that, I need to make sure that whatever I do to one side, I do to the other. So I'm going to, at first, rearrange this a little bit. I'm going to add 108 to both sides. The first key to this, really, is to get rid of 108, or get rid of any number without variables, and forget about it for a little moment in time. So what that does is it makes my equation kind of look like this. And that's not even good enough. I need to actually put my x's together and my y's together. So here's what I want you to do. I want you to write x squared minus 6x. And I want you to leave a little gap here. And then I want you to write y squared, because it's a positive y squared, right? So y squared plus 4y, and then also leave another gap and write 108. What's really cool is I can immediately factor each one of these in a separate way. And I'm going to do that work off to the side. So here's what I want you to do. You will always add to your x's and y's. But whatever you add to your x's and y's, let me change the color. You will also add to the other side as well, because you can't just add to one side without adding to the other. I'm going to make this first set of x's look like this. I'm going to make my set of y's look like this, and I'm going to show you how right now. What special h would work? Ready for this? Let's take our -6. Let's divide it by 2, and let's take whatever we get for a number and square it. So this is really the number -3, and I'm going to square it, and I'll get 9. So here's what I want to do. I want to add 9 to this side of the equation. Whatever I do to one side, I want to do to the other. So I'm going to write 9 right there. The next thing I want to do is I want to take the 4, the coefficient in front of the y now, and do the same process. So 4 over 2. So see how I had the -6? That came from there. This 4 comes from right here. So 4 over 2. And I don't skip a step. Listen to me. Write out 4 divided by 2. Actually write what it is. Just like -6 divided by 2 is -3. Write out 4 divided by 2 is 2. And then do your squaring. So now I have +4 and +4. Now, would you agree? I could have really pulled the 9 and the 4 away from the 108. I could have like not moved the whole 108 over, but it's just much more simple to move 108 over and get it out of the way and ignore it. Add 9 to the part that you need and add the 4, and whatever you do to one side, you have to do to the other. Let me write this a little bit smaller. There we go. All right, so this work that I did will not go unnoticed. If I want to factor this right here, this is going to factor into x minus 3 squared. Where did the -3 come from? Right here. So, oh, whoops. I meant that to be a 2 when I rewrote it. So yes, the -3 comes from right there. If I take my middle x term, -6, and I divide it by 2, I get -3, and I square it, I get 9. 9 is what I had to add to it, so which means I had to add to the other side. But it also perfectly sets me up for that binomial that can be expanded. X times x is x squared. X times -3 is -3x. -3 times x is another -3x. That's this one right here. That's my 6. And then -3 times -3 is 9. So I did all of the algebra out, but it's called completing the square. So that worked out really nicely. Now check out this one. I get plus y, and then what did I get? Oh, I got a 2. Okay, so it's y plus 2 squared. All I'm doing is taking the numbers I added to each one of them, which really could have been broken off the 108 before it moved over. But again, get it out of the way. I now have a perfect h and a perfect k. And then the last thing I have to do is look at the other side. What is 108? 108 plus 9 plus 4 is 121. Now I'm done. That is the equation in standard form, which is awesome. That is my equation in standard form, and I am done. Let me do that again. So x cubed, x minus 3 squared plus y plus 2 squared equals 121. So I made that equation right there into the other one. And just as proof, I'm going to graph both of these in Desmos. Whoops, that's not what I wanted to do. Okay, so what I want to do is I want to try to run Desmos as I'm doing this here. So I'm going to graph both of these. The first one's going to be x squared plus y squared minus 6x plus 4y minus 108 equals 0. And you see Desmos was able to graph this in red. Now I'm gonna take this other one, the standard form of the equation, and start typing this one in. So x minus 3 squared plus y plus 2, I have to use my parentheses for this, obviously, squared equals 121. Now, if this is the same circle, in blue, I think the next color is blue, it should perfectly overlap the current circle that's there. So let's see, 121. And there you go. So it doesn't matter which circle I'm talking about, they are the same circle. Again, just a little bit of rearrangement, and you are left with what you need. I'm going to do one more for practice. So again, ignore the 192 for this one. So let's move 192. What colors did I use? Okay, I'm going to move 192 to the other side. And at the same time, I'm going to set up for what I need. X squared minus 24x plus blank. Oh, maybe I should put a plus blank. Yeah, that's okay. Plus blank. And then I'm going to do plus y squared plus 16y plus blank. Oops. Equals 192. Sorry, negative 192 because I moved it to the other side. Okay, so now I take my negative 24, so negative 24 over 2. I square it, I get negative 12. This is important. The negative 12 is the number you use, but 144, so this is the number you use when you're writing your equation, and this is the number that you add to both sides of the current equation. So we have 144 is what we add to both sides. And then this one, I do 16 over 2 squared. So I get 8 squared, which is 64. Now I add 64, I add 64. And these, oops, move them out of the way a little bit. Okay, so when I go to set it up, I go to write it like this. I'll use purple. X minus 12 squared, because this is the 12, the minus 12. Okay, so you're using the exact number you see. Don't try to do the opposite of negative 12. You literally write the exact number that you get when you do this term, B, like ABC, right? Your B term in your quadratic. When you divide it by 2, that's the exact number you use. And we get plus y plus 8. So again, the exact number you use, and then we get equals, and we got to do a little math. We got to do 192, which is negative. So let's do 144 plus 64. That's 208. Take away 192, and we get 16. And there you go. You're done. So if I want to make this conclusion, the center of this circle is 12 comma negative 8, and then it has a radius of 4. 12 negative 8 with a radius of 4. Again, I can bring up Desmos. I'll do this real quick. I'll do these two circles just to prove that they're the same. I get minus 24 x plus 16y is plus 192. So I change that one. This other one is minus 12 plus 8. And then this is plus 16 Oh no, it disappeared. Oh well, let's try it again. X minus 12 squared plus y plus 8 squared equals 16. And right there, you see it overlaps the circle. If I go to look, let me see. Looks like, yes, there's a center at 12, 18, 12, negative 8. I don't know if I can, oh, well, let me find that. I can graph that, 12, comma, negative 8. I'll graph that location, 12, comma, negative 8. That's my, I'll throw a label on it. That's your center. And then you have a radius of 4. And because these grids are counting by 2 units. So there you are. That's your, I'll try to graph that one. Looks like it's 12, negative 8, so y equals negative 8. There you go. And let me do a constraint here. Perfect. Starts at 12, and it should go to be, oh, this is y, huh? Y equals 12. Okay. Let's try this one more time. Y equals 12. No, y equals negative 8. And I'm going to try this. Huh. Whoops. Let me go full Desmos and bracket. I'll go between 12 and 16 because that will be that'll be my radius right there. I just put a bracket on it. Whoops. There we go. And that shows between 12 and 16, that is a difference of 4, and that's what I just graphed for you to see. All right. So I'm done with the notes. So practice, practice, practice when you want to at home, if you want to. We're going to also be doing this one in class. So this is why I figured if you watch this all now, you can practice all of these, practice all of these, practice these. Let's stay away from the worksheets for now, just the homework problems and the CUDA problems, and then we can go to these worksheets like right here, the practice ones, if and when we have time. Okay. All right. Good luck. Thanks. Make sure you take all these notes, and you're fully prepared for Wednesday.